Hello students, welcome to Nilachal Polytechnic. Myself Amarendra Mishra. In the earlier video class, we have observing that how the pressure of liquid is varied from free surface to the bottom of the container. There are two figures. In first figure, we are having there is a liquid column. The A is free surface of liquid, H is the height of liquid. We are observing that as the height of liquid is increasing from the free surface towards the bottom, the pressure energy also increases. Now, according to that formula P is equal to rho GH, for each point there is a individual pressure, and the pressure is gradually increasing from free surface to that of the container. The BC showing that this line suggesting that the pressure energy of liquid or the pressure of liquid is increasing from free surface to the bottom surface. At the C point it is maximum, at the B point it is 0. Similarly, in second figure, if you are considering the atmospheric pressure upon the liquid, this triangular section also consider, but with that another rectangular section is suggesting that atmospheric pressure. The atmospheric pressure is constant, but from B point to C point, that is the same variation of pressure will be there. Only there is a cause of atmospheric pressure which is responsible for that. Now today we'll discuss about the types of pressure. Basically, there are four types of pressure. One is atmospheric pressure, absolute pressure, gas pressure, and vacuum pressure. Let's go for atmospheric pressure. Atmospheric pressure means what? In our atmosphere, atmospheric air is present. The atmospheric air has a weight, and that due to the weight of the atmospheric air upon the surface area of the atmosphere, that causes the pressure. If you are considering that atmospheric pressure in terms of your height of mercury, height of water, then it will be obtained as head of mercury and head of water. Generally, the atmospheric pressure is measured by the device that is known as a barometer. In barometer, we are going to take the vacuum glass. The vacuum glass is open to the atmosphere. While the atmospheric pressure enters that will create a effect, and that effect showing that the mercury is rise of its height, and that piezometer tube gives us the height of liquid of mercury is 760 mm. So 1 atmospheric pressure is expressed in terms of Hg as 760 mm of mercury. If you are considering the sea water, at the sea level, the weight of air is acting upon the free surface of water, and we are considering that if you are considering the head of water with respect to the atmospheric air, then it will be obtained as 10.33 meter of water. Generally, we are taking, if you are considering in bar, then 1 atmospheric pressure is equal to 1.01325 bar. Let's come to absolute pressure. Absolute pressure means what? Generally, while you are going to measure the pressure of liquid, absolute pressure of liquid, there is a absolute zero line. From that reference line, we are going to find out the total pressure exerted on the liquid. The total pressure measured with reference to absolute zero is known as your absolute pressure. Next comes to gauge pressure. Gauge pressure and vacuum pressure both are measured by the pressure measuring instrument, that is pressure gauge. As the name indicates that gauge pressure, this is the pressure of liquid measured with an instrument in which the atmospheric pressure is taken as datum or gauge pressure. It is measured by the pressure gauge, and the pressure of liquid is more than that of the atmospheric pressure. It is also treated as positive pressure. If we are considering about gauge pressure and atmospheric pressure and absolute pressure relationship, we are getting absolute pressure is equal to atmospheric pressure plus gauge pressure. Similarly, vacuum pressure. Vacuum pressure means what? It is the pressure of liquid measured with an instrument in which the atmospheric pressure is taken as data. So, it is always measured, the value is remain below the atmospheric pressure. As shown in the figure, we are having a absolute zero line. There is another line. This horizontal line is known as your atmospheric pressure line. After that, there are 2 points, A point and B point. The A point suggesting that the pressure of liquid at this point is more than that of the atmospheric pressure. So, this pressure is known as your gauge pressure. At point B, the pressure is measured below that atmospheric pressure, and that is known as your vacuum pressure at point B. The total pressure from absolute 0 point to that of A point is known as your absolute pressure with response to atmospheric pressure and gauge pressure. Similarly, from atmospheric pressure below B point vacuum pressure, that is obtained as absolute pressure is equal to atmospheric pressure minus vacuum pressure, that is your absolute pressure at point B. So, it is clear that absolute pressure is equal to atmospheric pressure plus gauge pressure. Another is absolute pressure is equal to atmospheric pressure minus vacuum pressure.